20, 30, 40, 50. 50 degree, exactly. 50.0 degree, exactly. 3 significant figure, please. 1 mark. So, in what situation? Complete the path of other two rays after they strike X and Z. Not necessary. Show add information to 4 marks. Now, any angle that is beyond the critical angle will be total internal reflection, right? Anything that is lesser, so let me write here, any angle is greater than critical angle will be total internal reflection. So take note of that. Okay, now you have to draw to scale. Okay, so normal. Let's find what's the angle of incidence here. It is 30 degree. 30 degree here. So how do I? This is definitely less than the critical angle, therefore refraction takes place. But how much to refract? We need to calculate. Alright. First of all, I need to calculate the refractive index. What is the refractive index for eye? Clueless. I don't know. Panic. Don't panic. It says show working at information. That is when you need to do your calculation. There's two formula. I think I work on this working here because of the space constraint. I work on the formula here, okay? First formula, we know the critical angle. We know that the formula for the critical angle is n equals to, this is my refractive index. So 1 over critical angle 50. And my answer would be 1.31, 3 significant figure, my refractive index. Okay? Using this refractive index, I move on to another formula, sine I over sine R. With this as 1.31, my incident angle is 30. My refractive angle, what will it be? Cross multiply. Okay, sine 30 is okay. Coming back to the question just now, I realized I made a mistake. Okay, now this I make a careful measurement is, if you look carefully, it hasn't reached 30 degrees, about 27. Okay, so can you please make the changes? It is 27 degree. So instead of sine 30, it's sine 27 degree, right? So coming back to here, if I sine 27, my incident angle is 0.454 divided by sine R, cross multiply, my sine R will be 0.454 divided by 1.31. Okay, and my R will be 0.34 sine R. R will be the inverse sine of 0.34 it will turn out to be 19.9 coming to degree, around 20 degree. So I'll measure about 20 from the normal. Okay, class, I would like to, realized something, and I would like to take this opportunity to teach you this item, which I think I have never taught you during the lesson. Now, I realized that when my refractive angle is 19.9 or 20, you will realize that this is 27, but my refractive angle will be 20. You may not see there's any problem, but there's a big problem because remember I taught you and it's written in your exercise book, when the light rays goes to a less dense, it should reflected away from the normal because it move, the speed of the ray will move faster from liquid to air. But instead of moving away, it moves nearer, it becomes 20 degrees. So there must some problem with our calculation here. So my apologies, I know that this is the third time of doing. Clean away all the working. And I would like to emphasize on my item. Leave this as it is. It is still 1.31, the refractive angle. We leave this as it is, but clean away all the working that we did just now. Okay, I'm so sorry about it because I realized there is one mistake here. Okay, and it's a good way to teach you at this point. Now I would like to bring up this thing so that you can write it down in your exercise book. Can you please, if you have the exercise book with you, take out the exercise book and write this down. If you don't have the exercise book, write it on a foolscap paper and transfer to your exercise book and staple it on when I return the exercise book to you. Okay, now as is read here, at the glass air boundary or liquid air boundary, okay, meaning when the light ray, instead of coming from air to liquid, it is from a denser medium. For this case is liquid to air. Okay, we cannot write sine I over sine Y, which we normally do. Okay, for this case we cannot write x sine x xy. That means we cannot here take this as this incident ray and this refracted ray, as the angle of incident is not in air. Okay, for this case we have to apply principle of reversibility. We can solve the angle for reflection by reversing the direction of the light ray. So in this case we turn it around. Alright, so we don't say it refractive angle, but we turn it around. Instead of sine I over sine Y, it becomes sine Y over sine X over here. That means for this case, alright, instead of sine I sine Y, sine R, which is supposed to be the refractive angle, we take this as a liquid and an air. Okay, so this is angle L and here is angle A. So I'm going to write here. Okay, we are using what they call principle of reversibility because the angle of incident is not air. In this case it becomes, we reverse it, we take the one that is from the air first, sine air for this case over sine liquid. Okay, we take, I repeat, we take the one from the air first. For this case, y. Okay, sine air over sine L. We reverse it. Although by right it should be sine I incident over sine R. Okay, so we reverse it this time because the incident ray is not from the air. So equals to refractive index is to 1.31. This refractive index is the refractive index of the liquid. Okay, of the liquid. Sine air over sine L, which is what we measured here. Okay. Okay, we are there now. And then we cross multiply. Let me take out my calculator. Sine 27 is 0.454. Then I cross multiply will be 1.31, 0.594. Equals to sine A, and A is the inverse of this. Answer is 36.5 degree, and I'm right now. I'm correct now, because when the ray go towards the air, which is less than, the ray should be going away from the normal. Because the speed is faster, it will run away from the normal. So be careful when you use the protractor. The base should be always the normal. 36.5 is around here. Okay, and please indicate is 36.5, and that's my answer. Okay, we are not done with the question yet, so sorry. How about this? Angle of incident is 10, 20, 30, 40, 50, 60, 60, 65. Now 65, the angle is greater than the critical angle, so what happened? Total internal reflection occurs. Okay, so that's your answer, 4 marks. Okay, let's draw this. Shows a large mirror plane inclined to be horizontal beneath a pattern of high ceiling. We are supposed to 2 light rays strike the mirror. On the figure, continue 2 light rays and show how these rays are used to locate the image of point X. Label the position of the image. Okay, do not be afraid when you have a mirror that's tilted in this angle. All you need to do is tilt the mirror such that it's facing you, tilt the paper, and you may want to extend the mirror a little bit, okay, in order you to draw. Now please take note, when you are measuring the object distance and the image distance, your ruler must be 90 perpendicular to the mirror line. If not, you will be doing things like that, here, here, which is wrong. Okay, I repeat, when you draw the object distance and the image distance, your ruler must be perpendicular 90 degree to the mirror line. So if this is like, please all use dotted line unless you are drawing light rays. Okay, use dotted lines to indicate the distance unless you're drawing light rays. If this is 4 cm and this is 4 cm, okay, and if this is x, this is your image x I. Alright, and that this will give you I think 1 mark. Alright, the image, the position of image x, and you need to draw the light rays. Now what you can do is work backwards. That means I know where my image is now, so I work backwards like that. Remember, 2 rays coincide to form 1 point. So again, I use dotted line because this is not my actual ray. The reflected ray is here. And do not forget your arrowhead, my reflected ray. Here, 2 points to form 2 rays to form 1 point. When it's here, is my reflected ray, I use full line. And there you go, my 4 marks answer. What is the characteristic of this image? It's virtual, it's upright, and it has the same size as the object. Okay, finally, as I said, if you just want to check the answer, here you go. Question 1. Resultant force is about 81 Newton plus minus 2 Newton. Question 2. Question 2, B part 1. B part 2. Question 2B part 3. 3A. 3B. 3C. 4A. 4B. 4C. 4D. 5A. B. 6. Remember to copy the notes in your exercise book about the reversibility, critical angle, light rays, and the last one. Okay, get your correction done and submit your corrected answers to me the next lesson.